Okay, so I had solved this function, right? Right, this function. Let me get this research here. I solved this function, but I felt like this was not a good solution. So we will check. Let's run it. Okay, so what I created counters like for each. Then I just checked in the ransom tree if x is an if r number if a number was in the magazine. Okay, we are going through each character in the ransom note. Then we check if that character is not in the magazine, then we return false. And if the count of the letter in the ransom note is greater than the magazine, then we also return false. And if both of these conditions are false, yeah. So I can optimize it by doing this, adding a orange right here. Then we return false. So let me just try. Yeah, correct. Now my time is even slow. Anyways, okay. So yeah, it's correct because if X is not here, then why would I even check it? Right. So going to look for the solution, video solution.
Hey guys.
So let me just
It's Greg here. Let's solve ransom note, LeetCode number 383. So we're given two strings, ransom note and magazine, and we should return true if ransom note can be constructed by using the letters from magazine and false otherwise. And each letter in magazine can only be used once to make the ransom note. So let's look at some examples here. If we're trying to make the ransom note of just A, and we have the magazine letters of B, well, we don't have any A's, so that's definitely false. If we were trying to make the ransom note of AA and we had AB, that is actually still false because each letter in magazine can only be used once. We have one A, but we don't have two A's, so we still return false. But finally, in this example, we're trying to make two A's, and in magazine, we have two A's as well as a B. We have enough A's, and so we can return true. And by the way, ransom note and magazine consist only of lowercase English letters. Okay, so let's take a look at this example where we're trying to make the note of AAB, and the magazine we have is AB. And we know this should return false because we only have one A available, but we need two A's. Now, if we know all of the letters and the counts of those letters that we have available, that's going to be very helpful. So we're going to get what is called a counter, or is actually a hash map / dictionary. So it starts empty. We'll take a look at the A over here. And so we'll say, okay, well, that's not in the hash map already. So let's put it in the hash map with a value of 1. Now let's look at B, the second character. Well, that's not in the hash map either. Let's now have one of those. That is actually the end of the string. And so this is our counter. If we had more A's, for example, if we had an A like that, well, then we would increment the count and we'd see that that has a value of 2 now. Okay, so we get the count of all of the letters that we have in the magazine in this hash map here. We'll loop through the note, and so we'll look at the first character. Okay, do we have an A available? In constant time, we can do a O of 1 lookup into this hash map via the key. So we can say in constant time, yes.
Okay, so what I've thought about is after we go with the magazine, we can loop through this and we can subtract the count, right? We can do something like creating the counter. I don't need a ransom. I'll go for X in ransom node. Then if X not in here, then we simply did if, then we'll go if um, text of X is less than 0, right? Then we return false, right? Uh, is less than, sorry, less than equal to 0. So if it is equal to 0, right? And when we encounter, I want to decrement this, right? Else if X isn't, we decrement it, right? So let me try and run this. Okay, will this be faster than 27 milliseconds? Okay, I should not have created. Yeah, it is a bit faster. Let's get rid of this size. So magazine, creating counter for magazine, and then we simply check in here. Okay, so how can I optimize this? If X in mdict and mdict of X is greater than 0, right? Then we go this, else we return false. Yep. So X, if Xn, if X is in, and if X is not in, then we return false, greater than 0. So let me give it a try again. Okay, this works, and if I submit it, can I get a better result than 17? No. I feel like um, seriously, is logical that slow?
Yes, actually. We do have this in the hash map, therefore it is available. Now, since it is available, we don't have a problem making this, but we do need to say, well, we've used up an A. And since we only had one to begin with, well, now we don't really have any A's. So you don't really want to just put this as 0, because then if you were to look it up, you'd say, oh, we still have an A. No, you'd rather say that actually, if you have one left and we're about to use this, well, let's just delete it. So let's just actually remove this key value pair from the dictionary. And now it truly is like we don't have any A's left, and that's accurate. So now if we were to go over to the second letter in note, we would see that, oh, actually, we don't have any A's available, and this would immediately return false for our problem, because it means we're not able to construct the ransom note. We must not have had enough of the letter we're currently looking at. So let's say that our magazine was actually ABA. So if we were to build up this hash map, we'd see that, okay, we'll put A into the dictionary with 1. We see a B, so we'll put that into the dictionary with 1. And then here, we're building it up, we see A. Oh, we already have that in here, so that's actually like we had 2 A's, okay? So now we are at the end of this, and our hash map or our counter is built. Now, if we were to go through the ransom note here, we'd take a look at this A. Is that in our hash map? Yes, it is. And the count is 2. And so we want to decrement that. We want to say we had 1 less A than we did before. So now we are down to 1A. We move on here and we see another A. Yes, A is still in our hash map, so we are able to do this. However, we have no A's anymore. This would actually bring it down to 0. And so we'd rather just delete this here to say we don't have any more A's available. We've used up all that we have from the magazine. But that's okay because we go over here, we see the B, we have that, same thing, we're going to delete that, and our hash map is empty, so we have nothing left, but that's okay because we get to the end of the ransom note here, meaning we've constructed it, and that is a case where we'd return true. Okay, so that's really all there is to it. Let's code up this solution. Now I'm going to show you a few different ways to build up this counter. First, I'll show you the basic way that is the best for an interview, but it is a little bit slow if you're kind of coding on your own. We would build up a dictionary, and so we would say for each C in the magazine, if that character C is already in the counter, if we've already seen that character before, then we just want to write counter at C plus equals 1. So that sets the value at this character to go up by 1. We have 1 higher frequency of that character than we did before. Now, otherwise, if we haven't seen that character before, well, that means we now have 1 of those. So we'll set counter at C to equal 1. Okay, so that is the way that we'd build up this counter, and I do promise you this works. However, I'm going to do 2 different methods to show you a little bit faster and different ways to do this. Now, one way is called a default dict. So instead of using dictionary or hash map, we want to use a default dict. And this takes a parameter. It takes what you want to make the value a default. And we want to make it basically an int. You can't actually just set this to be 0. You have to set this to be int. But basically, you can think of this as the default for a value is now going to be 0. What do we mean by default? Well, now you can just write counter at C is going to go up by 1. This is crazy. This is actually all of the code that you would need here. We loop through the characters in the magazine and we immediately set counter at C to go up by 1. Now, in a normal dictionary, accessing a key in a dictionary where that key does not exist, that would actually throw an error. But in a default dict, it doesn't. If you look up a key that doesn't exist, it's going to immediately make it the default, which is an int, and that int, really you can think of that as 0. So this is going to make the value associated with this key a 0, and so if we hadn't seen this character already, it's going to start it at 0, and it's going to increment it by 1, meaning basically it immediately sets it to be 1. And otherwise, if we have seen that character before, it's going to look it up and set its value to be 1 plus what it used to be, so 2, 3, or 4, and so on. Okay, so default dicts are really cool, and I want to show you one last way to do this, which is going to be from collections, we're going to import counter, and what's crazy about this is that this is already done in Python. Going to import counter, and what's crazy about this is that this is already done in Python for us entirely. If you call this counter thing with the magazine, this is going to precisely do all of the code that we just wrote here. This line fully makes our counter. Counter is a dictionary or a hash map where its key is going to be each letter, and the value with each key is going to be the frequency or the number of occurrences of that character. Okay, so I did want to show you those solutions because I think they're very clever and you might see it in other people's code or want to use it yourself, but I am going to just revert this to the original solution because it's the most raw form for an interview. Now what we want to do here is see if we can construct the ransom note. So for each character C in the ransom note, we want to see, okay, if C is not in the counter, so if we don't have that character available, well then we can return false because we're trying to make a character that we don't have available, and so we cannot do that. Otherwise, we must have this character available, so it's in our counter. Now what is the frequency of it? Well, we can check if the counter at C is equal to 1, well that means we have 1 occurrence of this left. And so we're trying to decrement our occurrences, say we had 1 less than before, but if we only had 1, that's basically saying now, okay, now we have none of them. So we want to truly have none of them, which is where we delete counter at C. So that deletes the key value pair associated with that key, and so now we have none of that letter at all. Otherwise, it must be true that the frequency is greater than 1, so we strictly want to set counter at C to go down by 1. Okay, so we have 1 less use of that character than we did before. If we get all the way through this loop, that means we had no issues constructing the ransom note. Therefore, we can immediately return true that we can construct it. Okay, so the time complexity of this solution, well, we are going to loop through the magazine. Let's call that M. So the length of the magazine is going to be M. The length of the ransom note is going to be N. So basically, we loop through both of those. And so that's going to be O of M plus N. All of the dictionary stuff, like these lookups and incrementing the value, those are all on average constant time operations, and everything else we do in here is constant as well. So really this is just O of M plus N, and the space complexity of this, well, we are storing particularly the stuff in the magazine. So this is going to be big O of M. And the space complexity of this, well, we are storing particularly the stuff in the magazine. So this is going to be big O of M. Drop a like if this was helpful, guys. I hope.
Okay, so my solution here, it's okay. So we get rid of this part. Okay, so that's what he did. If x not in, here we written false. Okay, so this is my solution. It means a minute. I think it is. It runs a little better. No. Anyways, so okay. So the main problem is that we have constructed this. And what I want to do is for the LF, maybe I want to save the solution. So yeah,